All right, let's talk AWS Lambda. It's one of those services that pretty much everyone uses, right? But here's the thing. There is a massive difference between just using Lambda and really, truly mastering it. And that's exactly what we're going to do in the next few minutes. We're going to close that gap for good.
So we're going to take a little journey here. We're going from those common, oh no, why isn't this working, kind of pitfalls, all the way to the kind of deep knowledge that gets you that senior architect job. This is it, the pro's journey to mastering modern Lambda. Let's do this.
So what is the difference, really? What separates a pretty good Lambda developer from a great one? Well, it usually boils down to a super solid grasp of a few key areas. And we're going to kick things off with a big one, security and networking.
Okay, first up, permissions. This trips up so many people. Think of it this way. You've got two main types. The execution role. That's all about what your function can do. Can it read from that S3 bucket? Can it write to DynamoDB? Then you've got the resource-based policy. That's totally different. That's about who can call your function. Can API gateway trigger it? Can an S3 event? Getting this distinction right is honestly step one to building anything secure.
And that brings us to, oh man, one of the most classic Lambda traps out there. You do the right thing, you put your function inside a VPC for better security, and then bam. It can't reach the internet. It can't hit S3. Can't call some third-party API. What is going on?
So here's the deal, and this is the part you really got to remember. The moment your Lambda function attaches to your private VPC, it loses its default connection to the outside world. That's by design. It's now totally isolated inside your private network. It doesn't just get a public IP address anymore.
So what's the fix? Well, you have to give it a path out. And that usually means setting up a NAT gateway in a public subnet. And you know what's really cool? The old problem with this, that dreaded VPC cold start that used to add seconds to your invocations, it's gone. It's a thing of the past. AWS totally re-engineered this with something called hyperplane ENIs, which basically means that network interface for your function gets attached almost instantly. So yeah, there's literally no performance excuse anymore for not securing your functions inside a VPC.
All right, let's switch gears and talk storage. You've got two main choices. First, there's the TMP directory. This gives you up to a whopping 10 gigs of super fast temporary scratch space. Great for quick jobs. But what if you're dealing with something bigger, or you need to share files between different function runs? That's when you absolutely have to reach for Amazon EFS. It's your persistent storage solution.
Okay, so your code is deployed, you're done, right? Nope. A pro developer's job is just getting started. We don't just write code, we build systems that we can actually understand and debug. That's observability. And there are three pillars to this. 1. Structured logging. Use JSON. It makes your logs structurable and actually useful. 2. AWS X-Ray. This lets you trace a single request as it jumps from service to service. It's like a detective map for your application. And 3. Lambda extensions. These are amazing. They let you plug in tools like Datadog or New Relic without even touching your function code.
And what happens when things go sideways? Because they will. The old school way was to use a dead letter queue, a DL queue. But honestly, it was kind of like a black hole. The failed event went in and you got almost zero context about why it failed. The modern, pro way to do it is with Lambda destinations. Why? Because it doesn't just give you the failed event. It gives you the whole story, the full stack trace, the exact error message, everything you need to actually fix the problem. It's the difference between guessing and knowing. Now, let's look a little bit into the future. What's the next big thing for Lambda? Well, it's becoming the arms and legs for generative AI. Seriously. Think about it. When an AI agent, like one built on Amazon Bedrock, needs to do something in the real world, like check an order status or query a database, what's it going to do? It's going to call a Lambda function. Lambda is becoming the essential tool in the AI's toolbox.
Okay, here's a pro tip, like a you can do this tomorrow and see immediate results kind of tip. Switch your functions from the default x86 architecture over to ARM64, which you'll see as Graviton 2. So why would you do this? Because the Graviton 2 processor was literally custom built by AWS for cloud workloads. It's just way more efficient. And the numbers don't lie. You're typically looking at around 19% better performance for 20% less cost. And the best part? It's usually a zero code change kind of deal. It's one of the easiest, biggest wins you can get.
All right, we've gone over the concepts. You've seen the modern way of doing things. Now, it's time for the final test. Think of this as your senior architect interview. We're going to go through the top 5 questions that really separate the pros from everyone else. You ready? Let's see. Question number 1. You're on call, you get a panicked message from a teammate. My Lambda is in a VPC and it can't reach S3. Help. What's your instant diagnosis? What's the first thing that pops into your head? And the answer is attaching it to a VPC stripped it of its public internet access. That's the core issue. So to fix it, you need to configure a route out. You need that function in its private subnet to be able to talk to a NAT gateway that's sitting in a public subnet. That's its path to the outside world.
Okay, next one. You're in a design meeting and someone says, let's just use a DL queue for error handling. What is the single best, most practical argument you can make for using a Lambda destination instead? What's the real difference?
The answer is all about the data you get back. Destinations are just way, way better. A DL queue, it just gives you the raw event that failed. That's it. A destination, though, it gives you that event, plus all the rich metadata, the stack trace, the error messages, the stuff you actually need to debug the problem quickly.
Number 3, let's say you go into the Lambda console and you slide that memory setting way up. What else just happened? What other resources just got a boost?
And this is a big one. The key thing to know is that in Lambda, you don't configure CPU or network directly. Instead, they scale up proportionally with the memory you give the function. So more memory equals more CPU power and better network throughput. This is a classic performance tuning trick, especially for functions that are compute-heavy, not memory-heavy. All right, question 4. A classic architecture problem. You're building a data pipeline, and you've got this massive 50-gigabyte file that tons of concurrent Lambda functions all need to read from, and they need to do it fast. What do you use? What's the architecture? The only real answer here is to mount an Amazon EFS file system. That gives all your functions what feels like a local network drive. It's persistent, it's shared, and it has super low latency access. It is absolutely perfect for this kind of use case. And for our final question, this one's a real test of senior-level thinking. What is idempotency, and why is it so ridiculously critical when you're dealing with asynchronous Lambda functions? The answer comes down to one word: retries. See, asynchronous events, by their nature, can fail, and AWS will automatically retry them for you. Idempotent code is what makes this safe. It ensures that if the exact same event gets processed 2 or even 3 times, it doesn't cause a disaster, like charging a customer's credit card 3 times for one order. It is absolutely key to building resilient, reliable systems. So there you have it. You've seen the common traps, the pro-level techniques, and even a glimpse of where this is all going. You've basically got the modern Lambda playbook now. So the only real question left is, what are you going to build with it?